This is the video on membrane receptors. The postsynaptic membrane must have a receptor for the neurotransmitter for the signal to travel from one cell to the other. There are basically two types of receptors: ion channels and metabotropic receptors. When a neurotransmitter attaches to an ion channel, the channel will open briefly while the neurotransmitter is attached. The attachment to the channel is not firm. The neurotransmitter quickly releases the attachment and moves to another channel, opening it. This will continue until the neurotransmitter is either broken down by enzymes or taken back up into the signaling cell by reuptake transporters. This allows for a quick response to the signal. If the ion lets sodium in, the cell membrane will depolarize locally, and this is an EPSP. If the ion channel opens for chloride, the cell membrane will hyperpolarize locally, which is an IPSP. The second type of receptor is the metabotropic receptor. This uses a G protein and secondary messengers to change the cell membrane potential. This takes longer than the ion channel. The metabotropic receptor has a G protein attached to it, and it is sometimes called a G protein coupled receptor, GPCR. When a neurotransmitter attaches to the GPCR, the G protein is activated. The G protein consists of three subunits: alpha, beta, and gamma. With the attachment of the neurotransmitter, the alpha subunit breaks free from the beta and gamma subunits. This subunit can then either attach directly to the ion channel from the inside of the postsynaptic membrane, or trigger a secondary messenger to do this. This will then open the ion channel briefly for the influx of sodium or chloride, or possibly the outflow of potassium. The cell membrane can hyperpolarize or depolarize locally, depending on the ion channel. Because the G protein must detach and move to the ion channel, there is a time delay that is not present in the ion channel type of receptor. However, the G protein triggered ion channel will remain open for a longer period of time than the typical ion channel. The presynaptic membrane also has receptors. One type is an autoreceptor. This receptor will respond to the neurotransmitter being released from its own terminal and will either trigger more release or slow down the release of the neurotransmitter. This type of receptor modulates the activity of the signaling cell. Another type of receptor in the presynaptic membrane is a transporter. This is part of the reuptake system seen for some neurotransmitters. When the neurotransmitter is moving around in the synapse, it might attach to the transport, which will pick it up and take it inside the presynaptic membrane back to the signaling cell. This neurotransmitter will then be placed back inside a vesicle by another transporter, readying the vesicle for another release. This ends the video on receptors.